Okay, so we're going to do a bit of SUVAT for this question, question 3, for each part of the journey. So the very first part, it starting off at rest. So U is 0, accelerates at 0.4 meters per second squared, and then it gets to a speed of 16. For part A, we need the total time, and for part B, we need the distance. So I might as well just do both of these at the same time. So let's do distance first. So if I want distance, I want S, U, V, and A. So I should use V squared equals U squared plus 2AS. So V squared is 16 squared equals 2 times 0.4 times S. So 16 squared is 256. It is, I win. So that's 256 is 0.8 S. So dividing by 0.8 is 320 meters. And then also I need time. So for time, I'm going to do V equals U plus AT. So I've got 16 is 0 plus 0.4 times T. So T is 40 seconds. Okay, for the middle part of the journey, I maintain a steady speed. So that means that there's no acceleration at all. It already tells you that it does that for a distance of 2,000 meters. But we need to find the time. So I can use SUVAT, but because it's acceleration 0, I can just use speed equals distance over time. So the distance was 2,000, the speed, the initial velocity was 16, because we've accelerated up to 16, and that's times time. So 2,000 divided by 16 is 125. Okay, and then the third part of the journey, we're decelerating uniformly for 20 seconds, coming to rest. So I know I was going at 16. Tells me I'm doing this for 20 seconds. I'm coming to rest. So I know T is 20, but I need S. So I'm going to use S is a half U plus V lots of T. So that's a half times 16 times 20. So 8, 20 is 160 meters. Okay, so the part A was the total time. So the total time is going to be 40, 125, and 20. So that's 185 seconds. The total distance is going to be 320 plus 2,000 plus 160, so that's 2,480 meters. In terms of drawing this graph then, we're doing a displacement time, not a velocity time. So because there's constant acceleration, the velocity time graph would have straight lines. The displacement time would be a curved line. So at first, I'm accelerating from rest for the first 40 seconds, and that gets me up to a speed of 16 and a distance, we're doing displacement of 320. Once I reach that speed, I then carry on at steady speed, so the displacement time graph would be a straight line. That's for another 125 seconds, that will make it 165 in total, and another 2,000 meters, so that's 2,320. And then let's just move the camera over so you can see that a bit better. And then I decelerate for another 20 seconds, so it's going to be slowing down. So that's 185 and another 160 meters, so that's 2,480.